3, 2, 1.
Assalamualaikum and hi. My name is Muhammad Haikal bin Jamsari. My role in this group is as a leader.
Hi, Assalamualaikum. My name is Muhammad Affiq bin Amir Udin. I'm a problem solver. I was assigned to solve all the questions and their related problem based on the assignment given.
Hi, my name is Nurul Asyiqin binti Mawarid. I am the problem solver for this group and I'm assigned to solve all the questions.
Name is Muhammad Riza Azruddin bin Muhammad Aris. My role is a collaborator. I'm assist to check all the answers that the problem solvers have done.
Okay, for the minute meeting, we use same medium, which is Google Meet. We meet together at 9 p.m. until 11 p.m. But every meeting we do different activities and discussion. Okay, for the first meeting, we do 3 discussion, which are first is we find the question for every part 1, part 2 and part 3, and then problem solver and collaborator doing draft for every part 1, part 2 and part 3. After that, we do by our own and discuss at the next meeting. For the second meeting, we discuss the answer that we get. After that, we point out the problems and solve it together. After we done solve the problem, we give task division to do report. Okay, last but not least, we do last meeting for recheck our report to make sure that all part of report is complete. After that, we give task division to do video.
This assignment has 3 parts of question. I will explain all the answers in part 1. In part 1, we need to obtain a joint probability density function PDF of 2 random variables x and y and complete the following items. So, we have obtained f xy equal to x plus 3 over 2 y squared, x from 0 to 1 and y from 0 to 1, 0 otherwise. This graph has been sketched based on the interval of x and y here. Question A. State the source from where this joint PDF is obtained. We have obtained this joint PDF from the web, which is probabilitycost.com. Question B. Show that the joint PDF satisfies the properties of being a PDF. To show that the PDF satisfies the properties, we need to show that the double integration of f x y must be 1. First, we set the limit for x and y. From this graph, we know that the limit of x from 0 to 1 and y also from 0 to 1. After that, we integrate with the x first. Substitute the value 0 and 1 in x and we get this. Lastly, we solve the integrate with dy. Substitute the value 0 and 1 in y and we get the answer is 1. Therefore, the joint PDF satisfies the properties of being a PDF. Question C. Find the marginal PDF for x and y and show that both marginal density functions satisfy the properties of being a PDF. First, we find the marginal PDF for x and y. For marginal PDF of x, this is the formula we use to find the marginal PDF of x. We integrate with dy and substitute the value 0 and 1 in y and we have the marginal of x is x plus half. For marginal PDF of y, we use this formula, integrate with dx. Set all the limit of x, integrate with dx, and we substitute the value of 0 and 1 in x and then we get the answer for the marginal PDF of y is 1 over 2 plus 3 over 2 y squared. Next, we need to show both marginal PDF for x and y satisfy the properties of being a PDF. Both marginal PDF we need to show that equal to 1, so it will satisfy the properties of being a PDF. We integrate marginal PDF of x with dx and marginal PDF of y with dy. Then we solve the integration and we get both the marginal PDF of s and y is equal to 1. So both marginal density function satisfy the properties of being a PDF. Question D. Determine the covariance and correlation of s and y. We find the covariance first. The formula of covariance is ESY minus ES multiplied with EY. So based on the formula, we need to find expected value of XY, expected value of S, and expected value of Y to get the covariance. First, we find ES with the formula integration of S dot GS dx. GS is the marginal PDF of X. After we multiply S and the GS, we get integration of x squared plus 1 over 2x dx, and we solve the integration and we substitute the limit 0 and 1 into s, and we get the final answer is 7 over 12 for EX. To find EY, we use the formula integration of y dot hy dy. Hy is the marginal PDF of y. We multiply y with the hy and we get integration of 1 over 2y plus 3 over 2y cubed dy. And we solve the integration, we substitute the limit 0 and 1, and we get the answer for EY is 5 over 8. Then we need to find EXY using this formula. Double integration xy dot fxy dx dy. Then we multiply xy with x plus 3 over 2 y squared, and we get x squared y plus 3 over 2 y cubed x. And first we integrate with dx and we substitute 0 and 1 into s, and we get this one. Lastly, we integrate with dy and we substitute the limit 0 and 1 into y, and we get the answer for EXY is 17 over 48. Now we have all the values for EX, EY, and EXY. Substitute all the values in the formula and we get the answer for covariance is negative 1 over 96. The question also asks to find the correlation. The formula of correlation is covariant xy over surd variant x multiplied with variant y. We just have covariance, so to find the correlation, we need to find the variance of s and y. To find the variance, we need to find EX squared and EY squared first. We find EX squared by using the formula integration of x squared dot GX dx. GX we get from the marginal PDF of x, and after we multiply x squared with GX, we get x cubed plus 1 over 2 x squared dx. We solve the integration, we substitute the limit 0 and 1 into s, and we get the answer for EX squared is 5 over 12. For EY squared, we use this formula integration of y squared dot hy dy. Hy is the marginal PDF of y. After that, we multiply y squared with hy and we get 1 over 2 y squared plus 3 over 2 y to the power of 4 dy. Then we solve the integration with dy, and we substitute the limit 0 and 1 into y, and we get the answer for y squared is 7 over 15. After that, we can find the variance of x and y. This is the formula to find the variance x. We substitute the value for ex squared and ex in the formula, and we get the variance x is 11 over 144. For variance y, this is the formula to find the variance y. We substitute the values for ey squared and ey, and we get the variance of y is 73 over 960. Now we have all the values to find the correlation. We just need to substitute all the values into the formula, calculate using the calculator, and we get the correlation is negative 0.13667. From the values of correlation, we can conclude that they have no correlation.
Part 2. Create a scenario that can be translated into a joint probability function problem and complete the following items. A. Define the discrete random variables x and y and identify all possible values of x and y. A fake coin tossed 3 times independently. Let x denote the number of heads on the first toss and y the total number of heads. This is the tree diagram. This is for the first toss, this one for the second toss, and this one for the third toss. B. Tabulate the joint probability function of x and y. For x, 0 and 1. For y, 0, 1, 2, and 3. And the value here is we can get from the tree diagram at A. So fxy is joint probability function. For C, give an example of pxy equal to y and obtain the corresponding exy equal to y and variance xy equal to y. We assume that for y equal to 1, this is the formula. Then for fy1, we can get 3 over 8. For fxy equal to 1, substitute into the formula, then we can get 8 over 3 fx1 for x, 0 and 1. fx0, y1, so we can substitute it from formula, then we can get 2 over 3. For fx1, y1, we substitute it, then we get 1 over 3. exy equal to 1, this is the formula, substitute the value, and then we can get 1 over 3. For variance xy equal to 1, this is the formula. Substitute the value, then we get 2 over 9 for the variance xy equal to 1.
Alright, I will continue with part 3. For A, we need to obtain a moment generating function for a random variable which follows one popular distribution, and our group choose exponential distribution. And this is a probability function for exponential distribution with x is larger than 0. To find the moment generating function, we need to integrate the function with e power of tx from 0 to infinity since x is larger than 0. And we get the answer is lambda over lambda minus t. We find the exponential distribution from statistical tables for engineering and science students. Next, for B, find the expected value and variance. So basically, expected value is the mean. To find the mean, we need to differentiate moment generating function with t is equal to 0, and the answer for mean is 1 over lambda. To find the variance, first we need to find the expected x square, which is to differentiate moment generating functions twice and substitute t with 0 and we get 2 over lambda square. And the answer for variance is 1 over lambda square.
Okay, for this assignment, what we get is we know more knowledge about this topic, and then we know how to use formula to solve the questions. And then congratulations to all my members because they do their part and they give 100% commitment and good cooperation to complete this assignment. Lastly, my group have done complete this assignment before the due date. Thank you.
The end.